Good day, folks. Welcome to my YouTube channel. Today we're going to look at the question on vertical projectile of motion on hot air balloon. This question, it says a hot air balloon is rising upwards at constant velocity. That's very important. Constant velocity, that means its acceleration is what? Is zero. Now it says when the balloon is 100 meter above the ground, it is the hot air balloon. Um, um, Above the ground, the sandbag is dropped. That's a very important statement. The sandbag is dropped. If you look in the diagram, there's the sandbag is dropped there. So we're going to choose upward as positive. Very important. That means our gravitational acceleration, which is g, is equal to negative 9.8, which is it's going downwards. It's very important that. And another thing, when if you watch my previous videos on hot air balloon, if an object is dropped there, it will take this motion. It will go up and reach the maximum height and go down. It's very important, right? So the initial velocity of an object is not going to be equal to zero. The initial velocity of the sandbag, which is the object, it's going to be equal to the velocity of the hot air balloon. That's very important, right? Let's look at the motion. This object, as I mentioned, its initial velocity is going to be 5, which is positive 5, and then the positive 5 will decrease and be 0 there. So there at the maximum, the velocity is what? Is 0, and the velocity here it's 5, and then it would go back, it will go down in the negative direction. It will start from 0 and increases. So when it gets to this position, it will be negative 5, its velocity, and then increase further down to the ground and reach the ground with the final velocity that we do not know, right? And its displacement from here where it was dropped to here, its displacement is what? It's negative 100 meter. Negative 100 meter because it's going down. So this displacement from there to there, so it will be 0 there, and then from here till the ground, it's going to be 100, but be careful, the 100 is downwards and it's going to be negative, right? It's very important. Yeah, let's cut the chase. The 5.1, it says, what is the acceleration of the hot air balloon while the sandbag is in it? While the sandbag is still in the hot air balloon, what is the acceleration of the hot air balloon? Guys, since I've mentioned here already, it's moving at constant velocity, so its acceleration is going to be what? 0 meter per second square, right? The next question, it says the sandbag, what is the acceleration of the sandbag the moment it's released from the hot air balloon? So the acceleration of the sandbag anywhere in this motion, it will be 9.8, and it's very important. You need to state the direction. It will be 9.8 meter per second square downwards. Guys, you cannot say here negative 9.8 meters per second square. You should say 9.8 downwards. Every object, guys, in fact, its acceleration is going to be 9.8 downwards, not unless it's moving at a constant velocity, just like the hot air balloon, right? Now the question, it says calculate the maximum height above the ground reached by the sandbag after it has released from the hot air balloon. So guys, when it's released, it's going to go up and reach the maximum height. So when they say the maximum height from the ground, so they want this height from there to there. So what are we going to do? We're going to calculate this height from there to there, and then we add with this one. So when they say from the ground, you're not only calculating this, you're calculating this and you add the height that is already up above the ground. So it's going to be it's 5.2, and then it's very important to write what we have. So which segment are we going to use? We're going to use this segment from there to there. So let me make a little drawing there. So we're going to use that. The initial velocity is 5 and 5 meter per second, that is positive, and then the final velocity there is going to be 0 when it reaches the maximum height. So we want that displacement, so it's the displacement that we want there, and the displacement is going to be what? Positive. And we have the acceleration is 9.8, and the 9.8 is what? Is negative. Very important. Okay, now which formula are we going to choose to do that? So we're going to use this formula. Vf squared is equal to V initial square plus 2a change in y. And then we substitute now. Substituting, we have the final velocity, we have the initial is 5, acceleration, we want the displacement. So let's substitute. The final velocity is 0 square, initial is positive 5 square, plus 2a, the acceleration is negative 9.8, change in y. So we are anticipating a displacement that is positive. So it's going to be negative 25 if you take the 5 to that side, and then it's going to be negative 19.6 change in y, and then we divide by 19.6 both sides, 19.6, and then your change in y, it's going to be if you punch that in the calculator, you get 1,28 meter. So the 1,28 meter, it's this displacement from where it was dropped till the maximum height, but we want the height above the ground, right? The height above the ground. So we'll say height max, the maximum height, it's going to be 1,28 plus the 100 is equal to 101,28 meter above the ground. I hope that makes sense, kids. Okay, that's 5.2, that's now 5.3. Calculate the time taken for the handbag to reach its maximum height after it has been dropped. Still, we're using the same thing from here to here. From here to here. Guys, it depends on what direction you have chose this one. So depends on the direction, but here we chose upward is positive. So 5.3, we want the time from here to here. So here we have the initial, it's 5 meter per second. We have the final velocity 0. We have the displacement now, it's 1,28 meter. We have the acceleration, it's negative 9.8. It's good, guys, to remind yourself what you have. And then which formula are we going to use? Let's use this one. How about we use this on Vf is equal to V initial plus AT, because we have the final velocity, we have the initial, we have the acceleration, we're looking for time. So let's substitute. The final velocity is 0, the initial is positive 5, and the acceleration is negative 9.8, and we want time. So when you take the 5 to the other side, it will be negative 5, and then negative 9.8 change in t, and then we divide by negative 9.8 both sides, and then your change in t, it will be 0,51 seconds, right? And we can also, let's see if we can use this formula to look for a time, but it will take us longer. But we can use this formula that says change in y is equal to v change in t plus half at squared. As you should avoid this formula when looking for a time, because it will lead you to go to the quadratic formula. So what is the displacement? We have the displacement from where it was dropped to the maximum height, it's 1,28, right? And then the initial velocity is 5, and we're looking for time, plus half the acceleration, it's 9.8, and we're looking for time. So what are we going to have? We're going to have 1,28 minus change in t, minus 5t, plus 4,9, it's 4,9, half times, is it 4,9? Yeah, 4,9 change in t square equal to 0. And then you do the quadratic, and then your change in t, it's going to be 0,51, right, seconds. But guys, avoid this one when you want time. This equation, when you want time, avoid that. Okay, let's look at the last question. The last question, it says, calculate the total time taken for the sandbag to reach the ground after it has released. So we wanted the total time. We know the time from here to here, and it's the same time from here to here, right? But we want the time for the entire motion. So the only time we want is the time from here to here. Or we can calculate the whole time from there to there. Okay, let's first use this one. Calculated the whole time from there to there. So what do we have? 5.4. We're going to use the entire motion from there to there. So we have the initial there, which is 5, and from there to there we do not have the final velocity. But one thing we have, the displacement here is what? It's negative 100. As I've mentioned earlier, the displacement for the entire motion, it's negative 100, because from there to there it's what? Is 0. So the displacement of this is from there to there, so it's negative 100. So the formula that we're going to use here, guys, to calculate the time for the entire motion here, so we're going to use the formula that says change in y is equal to v change in t plus half a t squared. Why are we using this one? We have the displacement, we have the initial, we want the time, right? We want time, right? We have the acceleration. So in this one you can use it, but there is a better option. I'll show you the other option that you can use to calculate. So the displacement here, be careful, it's negative 100 because we chose downward as upward is positive. So the acceleration is what? Is 5. The initial, remember we're using the whole segment, right? We're not using from here to here. The only thing that we're using is the displacement from here to here. So it's 5 change in t plus half negative 9.8 change in t square. That we're looking for time. So we're going to have here 0 is equal to negative 4,9 change in t square plus 5 change in t plus 100. And then we want our a. This is my a, and this is my b, this is my c. I want my a to be positive, so I'll divide by negative 1 there. So it's going to be 4,9 change in t square minus 5 change in t negative 100 equal to 0. And then I'll do the quadratic. The quadratic is negative b plus minus b square minus 4ac will divide by 2a. And then change in t, my b is negative, this is b, and this is a, and this is c. So my b, it's negative, so I'll put in the bracket, it's negative 5, and then plus, so we use the plus, and then b, it's negative 5 square minus 4a, my a, it's 4,9. C, it's negative 100. So all divided by 2a, it's what? It's 4,9. And then the answer there, it will be 5,0 6 seconds. That's the answer there. I hope that makes sense. So the whole time from there to there, it's 5,06. Okay, now let's look at the alternative quickly. The alternative quickly, what I'm going to do, I'm going to calculate, I'm going to use this segment specifically, this, right? But what we know here, the velocity from here to here, it's what? It's the same velocity from here to here, same velocity. So, but it's going to be negative 5, right? And then, yeah, that's what we're going to do. And then, what else are we going to do? So we have the initial. So what are we going to do? We'll say change in t. So we'll use this one, vi, change in t plus half at square. We have the displacement is negative 100. The initial velocity is negative 5 from here to here. So the initial, this is going to be the initial. If we're taking this segment now, this is going to be the initial and the final, but we do not have the final. You don't have to worry. And the displacement downwards, it's 100, negative 100. So I'm substituting now. Because of space. Okay, I have the acceleration and I'm looking for time, and then let's substitute now. So it's negative 100 equal to the initial velocity, it's negative 5t, and plus half negative 9.8 change in t square. And then it's going to be we're going to have why am I stuck now? So it's going to be 0 equal to negative 4,9 change in t squared minus 5 change in t plus 100, right? Yeah, so this is going to give us, did I do it correctly? Okay, we started from here to here, the initial and the displacement, and we're looking for time. Okay, it's going to be that. Yeah, so it will give us approximately the time, that is 4,55. Okay, let me double check. It will give us 4,55 seconds. The time when you put that in a quadratic, and then the total time, it will be now the total time. It will be the 4,55 plus, because the 4,55, it's going to be from here to here, right? It's going to be from here to here, and then you already have the time from here to here. It was 0.51, and then another 0.51 there. So it will be 0.51 times 2. So it will be 5,06 seconds. I hope that makes sense, guys. Cheers, bye.